Next part will be again very hard to some of you because it's about whether you understand the word called rational number, which is it is a number which can be presented as fraction-like, where m and n are integers. Generally speaking, you can see rational number include four groups. They are integers, fractions, terminating decimals, and recurring decimals. What does that mean? So let's start from integers first. Integer itself 3, for example, so you definitely can present it as a fraction because you can just write 3 over 1. Or like, for example, negative 5 is negative 5 is negative 5 over 1, or like negative 10 over 2, etc. So you can present it as a fraction like with integers up and down. So that's why we call rational number. Fraction, of course, is fraction, so you can skip it. While terminating decimals, you can use the calculator called shift ABC, then you can turn it into a fraction very quickly. For example, this one is this one 1.25 is 5 over 4. You can try the calculator for this function, while minus 0.8 will be minus 4 over 5 here. All recurring decimals will be a bit harder. That's kind of a calculation you will learn in Form 4. But generally speaking, recurring decimal 0.3, it will be 9 over something over 9 if the first number is repeating, and is 3 over 9 is 1 over 3. While minus 0.45 will be, because it's first two numbers being repeated, it should be 99 at the bottom. That means it's minus 45 over 99, so which is minus 5 over 9. So you can, to be better in this chapter, then you can also try to remember these four groups of numbers. They are called rational number. Then on the contrary, what numbers are not rational, which we call irrational numbers? Generally speaking, they are third form. For example, square root 10, square root 3, or like minus square root 2, etc. Because when you check the calculator, the decimal numbers are very messy, you can't see the pattern, so they are generally called irrational number. Another irrational number that's worthy to remember would be the number pi, which again, it can't be presented as a fraction. Wait. Do you remember that pi sometimes we use 22 over 7 when you were in primary school? Yes, of course, but indeed 22 over 7 is an approximation of pi only. It's not exactly equal to pi. So that's why we won't say pi is equal to 22 over 7. Totally wrong. It's only an approximation. Indeed, pi itself, the very precise value of it, is an irrational number. So you bear in mind it. So now when you come to number 1, there are lots of questions over there. So you bear in mind that if the number, for example, including pi, then definitely it should be irrational. And then for numbers which is third form, it should be irrational as well. But there may be some traps like part D. Do you know what is it? Yes, it's equal to 4. So that's why it's treated as rational number. Now with the help of the table on top, so see whether it helps you to justify whether the numbers, the 5 numbers left behind, they are rational or irrational. While in number 2, so you need to turn the question into fraction form. So that's why you bear in mind that you can use the function in a calculator called shift ABC button, which may help you to turn decimal numbers into fraction. But for this, I think you can just write minus 3 over 1 by yourselves quite easily. Number 4 is hard. Maybe if you still have question, then you may ask me afterward in school. You are just discussing or thinking whether the following, whether the following number is a rational number. That means it's whether it's a fraction-like number in the end. And so I will say in this way, 1.3 can it be a fraction? Yes, certainly. 0.5 can it be? Is it a fraction-like number? Yes. So two fractions add up together. Do you think it's a fraction? Hopefully yes. So that's why we put a tick. Third form is not fraction, right? So if you times 2, do you think it's a fraction like? No, of course. So by these two ways, see whether you can help yourselves to do part B and D respectively. Next question, you can also use calculator help to justify whether it's a rational number or not. By calculator, you check for 1 plus square root 121 to see what actually it is. So let's take 5 seconds to do so. It's easy, so it's 12. So that's why it's an integer, which means it's a rational number, right? And the next, in part B, it looks like a third form, square root, that means it's irrational, isn't it? But because there is calculation on 12 square and 35 square, so that's why it would be better for you to check the calculator carefully. And you will see that indeed it's 37, so that's why you draw the conclusion by yourselves. Part C and D, I will be leaving it them to you, but how about you have part E? Do you think that this one is rational, irrational, as well as like, how about this one? So because it looks like identity, right? But with the help of calculator, you can check the results directly of these two expressions. And you check, let's check part E first. Part E, so now I'm checking my calculator as well. And you see it's very ugly, right? It's 9.89, 79, blah, 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 blah. So generally, if the number is very ugly decimal numbers without pattern, then you can say somehow it's irrational. So I'm not asking you to use the step, but write a step, but I'm just want you to use the calculator to check whether it's rational, irrational or not. F, by the same principle, you guess, well, it's third form, then probably it's irrational. But if you try your calculator carefully, let's try it together now. I give you maybe half a minute to do so. Can you see that it's 7.2? Or you use Shift ABC, that means it's 36/5. So we see that it's quite special, or actually the question is specially designed, because even though it's third form at first, afterwards sometimes it becomes a simple decimal number like 7.2. That means it can be written in fraction, or we say it's a rational number afterward. That's all for this session. Hopefully you have a better understanding of rational and irrational numbers.